this section. Cool. So, welcome once again, Autodesk Inventor and Plant Design. I'm going to be your host today, Quinn Kennedy, application engineer, part-time trying to take over the world as per usual. And if you do require my details, I do have my email address over here, which is quinn@mgfx.co.za, which you're more than welcome to send me any queries, etc. And I'm always happy to try and assist. Now, moving swiftly along. So a bit about our agenda today. So our introduction, where we currently are, the BIM environment and adding connections, including more data from the model, setting its imports and orientation location, shrink wrapping and simplification, exporting the ADSK out and into Plant 3D, then our outro and any questions that we've got from there on. So, firstly, we've already gone through our welcome. Why use Autodesk Inventor over the default Plant 3D? And what do I mean by this is you probably have noticed that when you are working within the Plant 3D environments and you're trying to model things up, such as pumps and, well, anything else really, you are restricted to using the default AutoCAD way of doing things. So even if you are a fantastic modeler in Plant 3D, or you can use the object creation tools or anything like that, you've probably realized that when you are creating it, it can be a little bit difficult to get exactly what you want. And you're very limited in some cases by either your own skill sets or otherwise how to get your orientation of your parts correct. There's a lot that goes into it. And if you've ever tried it, you probably understand exactly what I mean. Where Inventor gives you a much finer control over your different parts. So it's easier to make more complex components and much faster. Plus, also what you can do is in Inventor, you've got parametric systems. So meaning that you can update and change things on the fly in regards to whatever else you want to make it towards. Okay. Also, a lot of manufacturers do a lot of their work in-house. And the same guys who are designing an Inventor are either designing in Plant 3D or they've got other people that they work with that work in Plant 3D. So they can actually hand over their models. So in other words, they're doing the Inventor model, they're handing over to the guys that do the piping. So we reuse our data directly from Inventor, which also comes with one or two other little bonuses. Not only is it easier then for the people who are receiving it, but it's also easier for them to keep some of that information. And it just helps with this flow of information. Instead of having to continuously redraw, they are also speeding up their design process. Also, what they're working with, they know is what's actually going to be built. It's not a guesstimation. It's why one of the big things why I always say, and you'll also see a little bit later on when I show you a pump, I always try and get 3D models. If I'm working on any type of project or something, I will try and get a 3D model of that exact pump or tank or whatever it is. I try and get that. That way I know that when I put this in there, it is what is going to be on the site. The only thing that normally throws a spanner in the works, generally in my case, is civils, which, yeah, that's always fun, not the easiest to control. Moving swiftly along. So where do we find this? Well, if we go to our BIM content, we're going to go, so environments, BIM content, and then we're going to go to our pipe connectors. So I'm actually going to, because I don't like doing death by PowerPoint, I'm actually going to do a lot of this straightforward. So I'm going to go into my Autodesk Inventor, and as you can see, here's the pump I've already got loaded. Now, just holding on for 1 second. You may be wondering why we're going through this process and why I'm going to do a few of these steps later on. One of the problems that you've got, though, with using Autodesk Inventor is that when in Inventor, we draw things as they are and how they will be manufactured, which is great for us in Inventor and the manufacturers that because we know then exactly how things are going to be. We can perform analysis on it. We can do all sorts of nice little tricks with it. But the problem is when you're pulling it into Plant, because we're dealing with so many assets, it has to compute every single part of this assembly. For instance, it has to know that where all these holes are. It has to know how the chamfer is. It has to know how this fillet is on the model. And then it has to represent this across an entire plant, which is if you're dealing with lots and lots of different assets, it can weigh your model down significantly. And part of our process, what we're going to do is we're going to turn this into something like this. Looks almost identical, but you'll notice a few key things. For instance, excuse me. You'll notice that the holes are missing, and there's also a few chamfers, fillets, and a whole bunch of other things. Normally, I'd even take it to a point that I'd also get rid of the little fins, but I wanted to keep a little bit of artistic flair in this one. So this can all be done very simply with what we're about to do now. So as you can see here, I've got my pump model. By the way, this was just a pump that I pulled off the web. It's just one of the general inline pumps that you can get. And as you can see, it is in a assembly form already. So as I was saying beforehand, we're going to go to our environments tab. We're going to go to the BIM content. We're going to open that up. Now, this place is where the magic happens. I'm going to show you guys one or two things here. Oh, sorry. So does this simplify the model for plant? Yes, it does. And I'll get to that in a little bit. And you'll see the process of what I do. Basically, we're going to be using our shrink wrap substitute. But more on that in a little bit. I promise I'm not forgetting you. Okay. Here, we're going to go to firstly, our piping connector. So with our piping connector, now is when we're going to define how our connections are going to be in here for obviously our pipe connections. Now I'm going to show you guys a few quick tricks here, which is going to make our lives a little bit easier. So firstly, when you launch it, it's already going to be in select mode. So you don't have to click select mode again. Don't be like me the first time I did it and I clicked select mode and was, well, why is this thing not selecting? It's because it's already in selection mode. Now, when you're hovering over any of these little faces, it does also help to try and pan around to make sure that you're on the face. Hovering over the face, you can try and get it onto whichever outstanding point. So under here, I've got a raised face flange. So I'm going to try and get it on one of these outer circles, or you can just click the face. So when I've clicked it, it's tried to now guess what the nominal diameter is. It already, by the way, knows it's a circle. If you want to, you can leave it as undefined, but generally it's quite good at recognizing this type of thing. Firstly, it's recognized it's a circle, but the nominal diameter is 128.5 wada 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 wada. If I actually selected this again, and I try to select one of the internal ones, how's that? So previously, what I did is I selected the face there, and what it did is it looked at the outer radius, or outer diameter, or outer circumference, depending on whichever one you want to refer to here. So that's what I tried to guess was the nominal diameter. Obviously, that's not it. I also know it's not it because if you look at the pump data at the top here, the name of it is actually 80-80-200. So I know this is a 80 flange. I also have measured it previously. But now, because I'm selecting the internal one, it's selected the nominal bore of the pipe, basically the pipe coming through there, so it knows it's a 80. There's nothing wrong with you, by the way. If it was a different one, you could type in, maybe if this was a 65, type 65. In this case, I'm just going to leave it back to 80. So, like I said, this is just setting up the connection. But now an interesting thing here has actually happened, and it was very nice that it actually happened straight off the bat, because normally it's kind of a 50-50 chance I have that it will either work or it won't work when I'm actually demonstrating this. And what I mean by that is it's not that it's doing the incorrect thing, it's actually normally working straight off the bat. And that is the port direction. So the nozzle orientation over here. Now you'll notice it's got a green arrow pointing directly into the pump. Now, a lot of people think, oh, that must be the flow direction. Unfortunately, it's not. It's actually showing the port direction. We always want this to face out, pointing away from our connection point, because this is when I use this little flip button at the top here, make direction, it's going to flip it around and it's going to say, okay, the pipe where I'm piping from or piping to is going to latch onto this flange, and it's going to basically pull it in the direction the arrow is facing. So in other words, if I had it the other way around, it will try and pull the piping through the pump, which kind of doesn't work very well. In this case, it's going to pull it in this direction, and we'll go out and then we can pipe normally. Obviously, we're going to have to set a few more things in this flange before we're done, or this connection point, should I say. You can also use this diameter if you want to, and then it will try and match diameter. I normally, by the way, prefer to just use the nominal diameter over here instead of that. Under the system type, now this is where things get a little bit when people like to chop and change things. Over here, because we're importing from Inventor to Plant, unfortunately, there is a bit of give and take that you have to do with it. Unfortunately, I can't pull all of the data from Inventor into Plant. There are ways and means around it with using like Excel, etc., but that normally requires Navisworks as well. In this case, we're just focusing on the Inventor side. Over here, I'm just going to set it to either other or undefined. I normally set it to undefined so that it doesn't give any issues with any other data. And you'll probably notice that this has got a lot of information here. You can pull some of this information in, but it's kind of a little bit dependent as to what it's going to pull through. The major things we want to put here, or the major thing we want to put here, should I say, is our connection type. By default, it's normally brazed. We want to change this. In this case, it would be flange. Obviously, if it was welded, you'd put fusion or whichever other one fits over here. Most of the time, I'm going to be using flange though, because I'm normally doing this with flanged connection points. So, flanged. So just a quick recap. I assigned the pipe connector, made sure it was in the right direction, gave it a nominal diameter, or checked the nominal diameter, set the system type, and then made sure my connection type was correct. In this case, flanged. And now I'm going to click OK. So that's the one done. I can quickly do the other one as well. So pipe connector, see, 84. Let's make sure that's 80. Undefined. And then set that as flanged. Notice this one, by the way, selected straight away the correct way around. Nice. Okay, so now this is my basic pump setup. So with that, if I jump back to my section over here, there we go. The next thing we're going to take a look at then is about altering our building component itself. But before I get too much into that, I'm going to show you guys a quick tip here. What I'm actually going to do here is going to be a little bit strange, but I'm going to click finish the BIM component. Now, because this is, let me actually quickly show you the reason why I'm wanting to do this. I'm going to go back in there. Now, if I go author building components, one of the major things here that's going to give you guys an absolute headache is this local insert. What's going to happen, and I've actually left it on purposely in this model in my Plant 3D. If I click on here, you'll notice that it's got its point in the middle of midair, meaning if I bring this in, it's going to always bring this point that it's kind of sitting inside something, which, although it can easily be rectified and you can move things around, it's just a bit painful to work with. So instead of doing that and having this type of thing occur, what we're going to do is we're going to move this location insert. To do this, it's pretty simple, and that's the reason why I'm going to go back into my normal Inventor environment in assembly. And I'm just going to go to sketch. I'm going to create a sketch. I'm going to just quickly chuck it on the bottom there. And let's just, I don't know, project one of these things down. Nice. It's like it's just going to be there temporarily. Don't even really need to put that on. It's just something to give you a point of reference. A sketch. Nice. So all I've done now is given myself a nice point to work from. Now when I go back, just going to save. And when I go back into my environment, BIM content, back into my building author components, now my insanity will make some sense, is that when we go locate insertion points, I can now get a nice place to snap onto. I can click onto that point and go, okay. Notice it vanishes because if I go back in there, you'll see it's still in that area. I'll get back to this author building components in a second. I'm just going to quickly clean this up a little bit. I'm going to go finish content, and then you can actually delete that sketch off. And you'll notice, if I go back in here, my point is still set correctly, but I don't have the ugly sketch remaining. So it's just a little bit of a pro tip that I found that makes your alignment of this much easier. And now when I bring this in, it's going to be nicely over there. You could also have probably, if you wanted to make your life simpler, just used one of these holes, but you'll see that in a second that may be a bit difficult when we do the simplification. Okay, carrying on here with the building author components, you want to take a look as to maybe some information that you're wanting to pull across. So what you can do in here is, I'm not going to go too deep into this, but if you click your model properties, you'll notice that it actually can then pull this information through onto the model. So if you're saying whoever has designed it, model 007 and stuff, and you'll notice some of this information will be pulled across directly through into Plant. So it does help a bit. So that's just one way of pulling out through some of the data. I'm going to click OK. So that is basically how we can start pulling through some of this information. And the fastest way of actually doing it, really, I found. Now, it can, by the way. So, Gerard, you asked, is this BIM content creator for Plant only, or can it be used for Revit MEP? Yes, it can, by the way, but that you'd be using probably more of the ducting connectors, etc. Basically, this works, and you can actually create your RFA files. So this is not my area of expertise, but yes, from my understanding is you can actually do most of that stuff from here because it is an MEP connections. If you want to, you can actually work through it a little bit later. Just give me a shout, drop me an email, and we can talk more about it. This, though, is focusing directly on Plant, and Plant uses a slightly different thing, which I'll get to in not the step I'm going to show you now, but the next step, and you'll see, and I'll explain a bit why from there, because it's to do with the export. Okay. Now, the next thing I'm going to show you, now basically my setup on this is done. I have assigned my connectors. I have assigned in the building author as to what the location point. And then I have also basically assigned some of the model data that it's going to be pulling across. So with this done, I can now get into the juicy point of now shrink wrapping this item. Now, the thing is, if I were to just go building export building component, it's actually going to complain about this. You'll notice it actually asks me, because of the requirements, do I want to shrink wrap it? Because it wants to reduce the model complexity. So do you want to create one of the shrink wrap substitutes? I'm actually going to go cancel on this. If I click yes, it will just launch this in any case. I'm just going to preempt it and go shrink wrap substitute, and we've been given this interesting menu. Now, the amount of data you want to include in this is directly up to yourself, how much data you want to pull across, how powerful your machines are. It can be a bit complicated. What I normally do in this case, you can go components. I normally leave this as is for now. But for features, I'm just going to show you a quick way. Now, in features, we can choose as to what we're going to basically tell out, keep in, etc. And then create. is got some mostly stuff as to how it's going to, where it's going to put the information, how it's going to structure it, etc. One of the more interesting things here is over here under the style is it going to create, basically, is it going to merge everything into one? Is it going to keep the solid bodies with some seams in between it? Is it going to maintain each one as a separate solid? Or is it going to create it into a composite feature? And depending on what you want, these four little options, normally it's actually only three, and we don't normally use a composite feature too much. But normally I'd either select this one, so a single solid with seams, or otherwise a merging between all of them. So a single solid without any seams with it. This kind of sometimes gives you a slightly better export, but that in Plant is a little bit of a misnomer. You'll see why a little bit later. So I'm just going to leave that on there. And under my features, now, I highly recommend saving, because when you decide to do this, Autodesk Inventor can get a little bit upset depending on what settings you've got here. Because if you set it too fine or too small, it can sit here crunching for a very long time. What do I mean by that is these little settings over here. So first setting is it's not going to do anything. It's not going to remove anything on here. So I'm looking at remove holes. If I click this one, it's going to remove all detected holes and features. Basically, if it detects that there's any form of hole there, it is going to try and remove it. This can be a bit dangerous because it may detect something that you don't want in that. It's probably better to use the next one, though it's going to be a bit heavier on the processing power, is that it's going to detect all of the holes, as you can see by the tooltip, that is smaller than a certain given amount. So if I click on here and I can say, okay, everything smaller than, I don't know, 60. So basically what's going to do is it's all these little bolting holes, etc. It's going to remove, but it's going to keep like this nice hole over there where my pipe would be fitting through, because that should be, well, it's going to be an 18 nominal pipe. Remove all pockets. I don't normally want to remove everything. That way it fills up the inside, because there's no point in Plant for us having all the internals to being displayed. Because in this case, we don't really require all the internals. We're only interested in this case in the piping, the connections between them and the piping that goes from there. Remove all fillets. Yep, I'm going to keep that on. This can be a bit dangerous though, because sometimes what it'll do is if you've got like a large radius over there, it can present some weird outcomes. So what I normally do is I'll put on that, and I'll put in the maximum of maybe, let's say, 25. Remove all chamfers, and let's say I'm going to do that to about 20. Now, before we go gung-ho and just go okay or whatever, I normally go and say select I will detect the features. Sorry, not select the features. Now, when you do that, depending on how powerful your machine is, it may take a little while to do this. In this case, it's showing me now in the blue highlights as to what is going to be affected. So I can now quickly see, oh, wait, there's some interesting things here. Now, if you look over here, it's actually detected this footing. Now, this footing, maybe I want to keep some of this information here. Like, for instance, the actual L shape, and also maybe the bolt holes at the bottom. So what I'm going to do is I'm going to select my preserve features, and then I'm going to select these features that I want to keep in here. You'll notice they're going purple. Can take a little bit of getting used to as to what it's doing here. Okay, now that I'm happy about that, so this is everything I'd want to be to take across. I'm going to click OK. I could also click Preview and it would give me a preview, but in this case, I'm fairly certain about what it's going to give me. Now we wait one eternity, and voila! You notice it's not incredibly different, but it's close enough. It's removed those fillets, even the little ones over there. We are still left with quite a nice detailed model, but it's not overly detailed. It doesn't have some of the other weird and wonderful bits and pieces in. You could even take it further. You could make it more and more simplistic depending on those different filters we've got in it. But for this is actually quite nice. It's going to be a lot lighter on the system. So I'm going to save it. By the way, just an interesting thing here. I'm just going to click at the BIM environment for a sec. Is that this is actually now, you'll notice it's done a substitute. You still actually have all of your other level of details, if you go to level of detail, in here. So you've got your original ability to have this. So you can have a high detailed model, or you can switch to your substitute level. This can also be used in normal Inventor as well. And I use this as myself when I've got stupidly large assemblies of maybe 5,000, 10,000 parts. So what I'll do is I'll take my sub-assemblies and I'll actually create these substitute levels of detail and then flip them out and swap them out to just increase my just increase the flexibility, decrease the time it takes to actually load and compute these. So it's not, instead of computing every single part in an assembly, it's just looking at the substitute level of detail. So just a pro tip, I find it works really nicely for myself, especially in things like large conveyor systems, etc. But for now, I'm going back to my environments tab, BIM content, and we've just shrink wrapped. Notice the shrink wrap has become grayed out. And now I'm going to do the interesting thing, the export building components. Now, Gert, you just said you asked about the exporting to Revit. Now you can actually see in here we can export to a Revit family file. So normally this would probably be for your other MEP systems, etc. In this though, unfortunately, Plant does not see RFA. It only sees ADSK, which is a slightly older export type. They haven't really changed that yet for some reason. It does also now have the ability though to export into an IFC file if required. I'm going to mostly use the drop down here and switch it to an ADSK file. Now, with an ADSK file, you can see I've already got one in here actually. So I'm going to call this V2. So I don't want to overwrite my last one. This is basically just a random location on my system that I've chosen just for this demonstration to show this off. But you can actually see it says .adsk on the end. Once you're happy with that and you like those locations, I can then go save, and then it will publish my model out. Like I said, just watch out, guys. This may take a little while to do, especially. Oh, so said, okay, this is awesome. Can you add parametrics to the BIM component? For example, different flange size and range in the same pump? Yes. It's a normal Inventor component. You can have your parameters running. You can have equations that also reference the parameters. You can create iLogic systems. It's up to you, actually. And you can do all of this. And then when you're exporting, though, just remember, when you're exporting out, because it's a different kind of file type, and unfortunately, due to the limitations of Plant at this stage, it doesn't have a direct connection back. So that ADSK file, once it's exported, kind of is broken apart. There's no linkage between it, meaning that whenever you update something, you will have to re-export it again. It's not a major problem, but just be aware of it and it won't catch you out. Sorry, I do apologize about the dog in the background. Okay, so for here, getting back to our export, you can see it says the operation was successful. Yay! The patient didn't die this time. So the detailed information is contained in a translation report, etc., etc. You can choose to open it, and if you do, it's going to open into a web page, and it will give you some bit of information about it. So it's going to tell you as to the different views, the step, any information in here, etc. Even with a nice little thing. How useful this is to you? That's up to yourself. Unfortunately, I am, yeah, it doesn't mean too much to me at this stage. Okay. Now, it's exported. Now comes the fun part. We're going to jump into plant now, and we're going to then see it in the plant side. And you'll see it's actually very straightforward and simple. Jumping into my plants area, you can see there's my original pump. Now what I'm going to do, firstly, I'd better change to my 3D piping. And we're going to go to our Convert Inventor equipment. Now you can see there's my original one that I had in there, and here's my new one. I'm going to go open, and voila. Now in here, when I put my pump in, I can click pump. So what this is doing is it's saying, where in Inventor does it want us to then locate this? So the pump, because it is a pump, I'm putting it into the pump class. I'm going to select, and we've now got a new pump. You'll notice when I select on it, one of the big things, and the thing that I showed you to change, was the location. Because this one's location, the original one, without changing that import location, is now sitting in the ground. It's a ground pump. Unfortunately, that makes it a little bit more difficult to work with. With what I've shown you here, it's far, far easier to locate. Now, and there is one or two things you're going to have to realize when actually doing this import, is that although it does speed you up, there is one or two little things you have to be aware of. So when we select onto our model and we go edit nozzle, you'll notice it pulled the size across. It knows it's a metric because of the size that we used. End type, flange, which has already been assigned. But here's where the crux of the matter is, it does not pull across the pressure class, unfortunately. So you're going to have to know to change the pressure class. In this case, I think I had a class 10. Don't know what I actually had in this one. Yeah, 10. So what I'm going to do is I'm going to set it to a pressure class 10. Select that as the DIN. I'm just doing this as a demonstration purposes. Obviously, this would be to whatever nozzle you're using in your project. And go close. I'm going to do the same thing for the other side. So what I'm doing is playing match the pressure class, match the flange. Now what's really cool is that when I select onto my system, I should be able to just click. Oops. And the reason why it's done that is because I'm in custom parts. Let me click onto the right spec. And voila. And now we can be piping like pros. This basically makes our lives far faster and far easier. This allows us to, like I said, exchange data between our different teams. So team that's working in Inventor, team that's working in Plant, we can now share our data and actually work easier and faster. You also notice, like I said, with that simplification, I've even got my bolting holes that I left behind. It's part of the reason why I took a little bit of time to keep that information in. So this may help you in centering and aligning, etc. So moving swiftly along. So now that I've shown you guys these little bits and pieces, do you have any? Oh, yeah, better presentation on models. Yes. Well, basically that comes back to, sorry, you just asked a better presentation of model. Yes. So it allows you to create much better, much more higher definition models, but also without having to include too much data. So although it looks better, it looks more realistic. It's not as heavy because it's not including all of the little. And if we jump back here, jump back to our master, it's not including all of the bolt holes, all of the little flanges, not flanges, fillets, chamfers, that type of stuff. It's including the necessary data, but without overdoing it. This is still going to be heavier, don't get me wrong, but it's not going to be as heavy as doing a direct import in. or otherwise doing like a AutoCAD insert. So in other words, if you to insert an AutoCAD block in and then create that into a plant asset, because there you've got far less of a way, well, uh, far less tools to get it as a nice culled down representation of what we want, a lower detail. This still looks good and is still very functional. So with that being said, is there any other queries that you've got so far? Yeah, anything not plant standard looks better than plant 3D info. Yeah, unfortunately, because it is limited to the, like I said, the AutoCAD background, there's so much you can do with it because of the complexity that goes in involved. Like I said, anybody who's used AutoCAD, any of the 3D modeling before, knows that it's not the, you can get, don't get me wrong, you can get as the same level of detail in AutoCAD 3D, but it's going to take you a lot more effort. Also, the problem being is because it's not parametric, your editing then is a little bit more time consuming, a little bit more difficult, but more time consuming than anything else, mostly due to the non-parametric parts of it. Okay, guys, and just one little tip for you guys is that, why does it not want to switch? Ah, there we go. Sorry, I've been trying to get it to switch to the slide. So just a bit of for ending off here is a bit about an outro. So if you're wondering like where I get a lot of this information from, or you're just trying to sharpen your stick of knowledge, or otherwise, if you also have any ideas. So firstly, IdeaStation for Autodesk Inventor. Okay, I do have this very long system that you can see online. I will try and include this link also then when I upload. By the way, these are all being uploaded to YouTube as well for if you want to look back on it or reference back onto it and into the future. I'll try and include this link also inside it. So the idea station basically is where you can give any of your ideas. So this is the Inventor idea station. There is also, by the way, a plant idea station. Because this is mainly looking at Inventor full plant, I'm just showing the Inventor one. You can either use this link or otherwise you can just Google Autodesk Inventor Idea Station. And also the same for plants, by the way, if you're interested. Just Google Autodesk and Plant Idea Station or Ideas and you'll get there. So I did also include this below over here. So it is in the forum side. And the forum side is Plant 3D PNID Ideas and the Plant 3D forum. It's full of amazing people who are always willing to help somebody out. And it really is a wonderful place to get any information from. I personally use this a lot myself. Well, guys, do I have any other last minute queries, questions, etc.? Cool. Well, thank you guys. Much appreciated for joining me here today. I really do appreciate it. If you guys need to get hold of us, please, as you know, we've got multiple offices throughout the country. Please take a look. So Johannesburg, Cape Town, Port Elizabeth, and Durban. I myself am in Durban. Notice actually address needs to change, but apart from that, it's all accurate. Yeah, and thank you very much. Thank you for joining me. Hope you guys have a wonderful rest of your day. Thank you. Cheerio.